The scheduling and physical structure of Eid al-Fitr are defined by a strict, deterministic mathematical framework. The patterns of the celebration, from the timing to the architecture, are generated by rigid, infinitely repeating mathematical and recursive algorithms. The architecture of this holiday rests on three distinct pillars. Mathematicians and engineers analyze the holiday as a specific real-world use case where complex, abstract formulas map onto global human behavior. To understand the mechanics of Eid, we must analyze its temporal, spatial, and theoretical constraints as one unified mathematical system. The entire timeline of the holiday hinges on a single astronomical trigger, the sighting of the new crescent moon, known as the Hilal. Common graphical representations of the crescent moon, usually two overlapping circles of different sizes, are geometrically inaccurate. Viewed from Earth, the moon's terminator line, the boundary separating day and night, projects onto our two-dimensional vision as an elliptical arc. We calculate its maximum width using W equals R times 1 minus cosine of theta, where R is the radius and theta is the elongation angle. A wireframe celestial sphere maps the observer's spherical trigonometry to find the moon's altitude using the ZPS astronomical triangle. The physics of human optics dictates strict angular constraints. The moon must be 7 degrees away from the sun and 5 degrees above the horizon. The precise start of the holiday is the deterministic output of this complex spherical geometry equation. The immense physical momentum of planetary bodies in our solar system ultimately dictates the exact timing of these human schedules. The solar year takes 365.24 days, while the lunar orbit takes 354.37 days. Subtracting the two reveals a predictable drift of 10.87 days backward each Gregorian year. Dividing the solar year by this drift yields 33.5 years for Eid to tour all 4 seasons. The holiday's movement through winter, autumn, summer, and spring is a macro-level application of modulo arithmetic and orbital mechanics. These calculations of time extend spatially to the environments where Eid prayers occur. In Islamic architecture, architects utilize exact mathematical construction rather than approximate methods. When multiplied across a massive courtyard, even microscopic errors in an approximation would compound and cause the entire pattern to fail. We trace the algorithmic construction of the Khatim, define a base circle, bisect a square, rotate a second square 45 degrees, and interlace the points. This regular octagon belongs to the D8 symmetry group, possessing exactly 8 rotational and 8 reflectional symmetries. The angles are mathematically constrained so they interlace continuously, covering flat two-dimensional planes without any gaps. Strict adherence to exact geometric algorithms transforms a plane wall into a mathematically proven tessellation. These two-dimensional concepts scale to 3 dimensions in the vaulted ceilings found above mosque entrances. Known as muqarnas, this ornamented vaulting is a 3D recursive algorithm engineered to solve the problem of transitioning a square room into a circular dome. The algorithm takes a single niche and recursively subdivides it into smaller, self-similar tiers, carrying structural weight downward through a series of interlocking units. Zellage tile work similarly employs aperiodic tiling, a system based on 5-fold or 10-fold symmetry that expands infinitely without ever repeating a strict grade translation. These spaces are physical fractals, using mathematical recursion to provide a spatial representation of infinity. Before the celebrations begin, the holiday enforces a set of mandatory financial calculations. Zakat al-Mal functions as an economic balancing algorithm based on the nisab threshold, a constant tied to the market value of 85 grams of 24-karat gold. If an individual's total wealth exceeds this threshold, a fixed percentage of exactly 2.5% is mathematically extracted and redistributed. By formalizing charity into a hard mathematical equation, the system functions as an automatic, society-wide wealth stabilization algorithm. While geometry and astronomy define the physical rules, mathematicians also use theoretical calculus to model the spirit of the holiday. This calculus greeting evaluates the definite integral of 1 over x, from the lower limit e to the negative Mubarak to the upper limit e to the power of Eid. We solve this by finding the antiderivative, the natural log, and substituting the limits. Because the natural log and the exponential constant e are inverses, they cancel each other out, simplifying the equation to yield exactly Eid plus Mubarak. An alternate approach uses the limit definition of the exponential constant e as n approaches infinity. Substituting the holiday parameters for x allows mathematicians to model the spirit of Eid as an exponentially compounding limit. From planetary orbits and architectural fractals to definite integrals, the universal language of mathematics provides the underlying structure for every component of the Eid celebration.